Hello everybody, this is a quick video to help you to understand and better figure out how this PowerPoint can be used to assist you in learning about various other aspects of water and the water topic that we're exploring in geography. This is one of the early activities in this sort of mini topic that we're exploring, and it gets us to start to record and think about some of the most important terminology that goes along with this topic. Right here on the very front page, it talks about how you're going to be using page 3 of your water resources intro booklet intertwined with this PowerPoint, and that's probably the single most important other piece you need in order to get the most out of this PowerPoint. So just quickly, I'm going to just show you. This is, if you got this on paper, then it's probably on beige paper. This is a beige water resources intro booklet that I would have referred to in class, and it is to be found on our website inside Unit 2. And now we are working just in the main part of Unit 2. We are no longer working in the ecological footprint subfolder. We're still using textbook study notes, except now the textbook chapter is for water. And what you see here then is several more pieces that have been laid out that all have to do with water and water resources and various files and activities for us. So what we're looking at a minute ago was the water resources intro booklet right here, a Word document for that booklet. And what you're going to be using to do part of that booklet, to fill in part of that booklet, is this PowerPoint, water terminology and activities. Okay, so using this order column here, we're talking about file number 6 and file number 7. And so to go back to the booklet, you would have been asked to work on the questions in the first 2 pages of this booklet by now, and at this point we are moving to the third and, for our purposes, the final page of this booklet. I know that there are a couple of other pages to this booklet, but we will not be using them, and instead just ending with the water vocabulary recording sheet here, okay, somewhere where we can record all these important terms all in one place. So this is the main page. Page 3 is what is designed to go with this PowerPoint. Okay. So with that said, what we'll be doing then is working quickly through the rest of this PowerPoint just to make sure there's certain terms that make the most sense, and you'll be asked to record the actual wording and definitions onto that page 3 of that booklet. So our first word that appears in the PowerPoint is aquifer. Okay, and there is a great video here, about 3 or 4 minutes long if I recall, and it's just a lovely little animated video which really does explain where water comes from, how it's stored inside the earth, and it talks very much about what an aquifer is. Okay, so basically an aquifer is part of the Earth's groundwater, right? Water, we've learned, can be stored on the surface of the earth or underground, and so an aquifer is an underground collection of water. I usually talk about it in class as like an underground lake, but that gives the impression that it's just this giant cavity, an open space underneath the earth that's filled with water. And that's not the case. The reality is that most aquifers, basically what it is that all the space between the rocks and sand and gravel are just waterlogged. They're filled with water at a certain point. If you've hit an aquifer, then more likely what that means is you've hit a pocket where there is water that is stored underground amidst all kinds of other minerals and rocks and sand and things like that. And so the idea here is that if this is one of the ways that we can access water, is to sort of stick the proverbial straw down into the ground and suck water up out of the ground and use it for whatever needs we have here at the surface where we live. So definitely watch this video. It gives you a great chance to sort of understand better and more visually how aquifers work, how they were created, and how they're used by humans nowadays. This is the information that we would like you to squeeze into that box on page 3 on that sheet. Okay. Now the next two words that are also in that same section of physical geography terms that have to do with water. One of them is watershed, and the other is drainage basin. And I'm going to start off right off the bat by acknowledging that in the outside world, these two words are often used interchangeably to mean the same thing. And what I'm going to do in this video is gently ask that you consider watershed to be a slightly different thing than a drainage basin. So we're going to skip the watershed for a minute and go to drainage basin directly and talk about it first. And what a drainage basin is an area of land, okay, that basically catches all the water that falls within it. Okay, and so on this map of Canada, what you see is a whole bunch of different drainage basins represented by different color coding. And this has been subdivided into many micro drainage basins here. There are several just giant drainage basins that we are going to ask you to be familiar with. For example, all the land that drains the water that falls within it into the Hudson's Bay is known as the Hudson's Bay Drainage Basin. And that drainage basin is sort of contained within this sort of line that I'm tracing here. And so there's like a subdivision here of drainage basins within that larger one. But you have to think about this as just a giant area of land where all the water that falls within it eventually flows to one body of water, and in this case it'll be the Hudson's Bay. Okay, another major drainage basin in Canada, and one that consumes a huge majority or a huge chunk of its land, is the Arctic drainage basin. And so that one applies to all the land that I am tracing here by my cursor, and all the rainfall that falls within, and all the snow that falls and then melts. Eventually that water, if it makes it before it evaporates or sinks into the ground or is caught up by humans for drinking water and other purposes, it will eventually all flow to the Arctic Ocean. And so that's why this area would be known as the Arctic Drainage Basin. Now there's a very narrow drainage basin here, narrow compared to these other two huge swaths, and this one would be known as the Pacific Drainage Basin, because all the water that falls within this boundary all flows eventually to the Pacific Ocean. And so what you learn is the drainage basins are named for the area of the body of water that they drain into. And so what we're doing with drainage basin is asking you to think of that as the giant area within which all the water that falls there will eventually flow to one place. What I want to, I'm going to go back now, we're talking about watershed. What I want you to think of the watershed as is the boundary between the drainage basins. And so when we think about a shed with a roof, for example, a peaked roof, the water is going to flow down one side of that peak if it rains on that roof, or it'll flow the other way down the other side of the roof. And so a watershed sheds the water into one drainage basin or into another. And so when you look at this picture, the area inside this dotted line, this large dotted line, is what I would want you to consider the drainage basin. And the actual yellow line is the watershed. Okay, so this is literally, in almost all cases in the world, because of gravity, a watershed is of the highest point of land that divides the flow of water from one drainage basin down to another drainage basin. So it is the boundary between each drainage basins that is created by the high point of land, just like the peak on a roof. Okay. Now, there's one other image here that I hope sort of explains this or shows this well. And again, what you've got are two drainage basins side by side, and the high point of land here is what I would want you to consider the watershed. Okay, but understand that there will be times where you read that word or hear it used to mean drainage basin. We're going to try to be a little bit finer on that word and give it a slightly different meaning. Whoops. So, with that said, that's the first three terms that go with this terminology sheet. Sorry, I'm trying to get it to open up. There we go. And so these three terms can be defined, and if you can draw a little sketch, a little thumbnail sketch to help understand that, great. You know, it's harder to do on the computer than it is on paper, so do what you can. The definitions are the most important thing. Okay. Now, when we go back to the PowerPoint, what happens here for a couple of slides is there's some instructions on how to use various worksheets and work with them. Some of these worksheets might have been handed out in class, and others students may not have access to. And so I want to be clear here that, for example, when you look at this slide and this page, you're able to, if you want, to sort of zoom in and take a look at this sheet, and you can read it and see that there are some blank spaces. Now, the first one there, second one, third one, fourth, fifth, sixth, and seventh. So when you go back to looking at this page, what you'll see is there are 7 bullets here. And while it's not easy for you to type these in on top of a PowerPoint, and if you don't have a paper copy, I'd just like you to at least read through this worksheet and understand that these blank spots should be filled in order with these terms and words. And when you do that, then you start to understand how water moves through the earth, which is one of the aspects that we'll be studying in these coming days. Okay, so the next page has a similar sort of set of instructions, and again what it's asking you to do is use this document, which you may or may not have on paper at home. And if you don't panic. I'm not going to be worrying much about mapping work right now. If this video is being watched by my pandemic people, then don't worry too much about this. But I would like you to understand that the major drainage basins of North America, which are labeled here on this map, they have names all for the body of water that the water flows into. So all the water that falls within this area eventually flows to the Atlantic, and that would mean that this is the Atlantic drainage basin. All the water that falls within this area of North America will eventually flow to the Gulf of Mexico. So this would be known as the Gulf of Mexico drainage basin. And yes, there could be micro drainage basins individually divided inside here, one for each river system, but I'm mostly interested in you understanding the big major drainage basins of North America. So hopefully that will tide people over for if you don't have a paper copy of this. Now you at least understand how this will work. You should all have this, and if you don't, you definitely can access this on our website. This is now the second of 3 pages in our textbook study notes for Unit 2. And questions 15, 16, and 17 are the first 3 questions on this page, or on these 2 pages that have to do with our water unit, our topic. They are the bolded questions on this side of the paper. And there are a few other questions on the other side that I'll also be asking you to do. But to start with, questions 15, 16, and 17 can be done at this time and would make sense based on where we are and what we're learning in this topic. Okay. Now, the other 3 vocabulary terms are more human geography concepts because they involve human activity and human interaction with the environment. And we go back to your water resources booklet and back to that 3rd page, and you'll see those 3 other words are there. And one of them is, what is a dam? And there's some pictures here of a dam that we're going to be visiting in a video that we'll be watching in the next few days. What is a reservoir? And again, a map showing the major reservoir behind Hoover Dam, which was featured in the previous picture. And then what is an aqueduct? And I want to just focus on this word. The other 2 are relatively straightforward, and you can read those definitions and copy them into the notes page when you get a chance, and review and study them until you have them understood. But aqueduct is a word I want to just spend an extra minute on here because it is so similar in its structure as a word to the term aquifer. And we learned a few minutes ago and just a few words ago in this PowerPoint what an aquifer is. That's an underground body of water, okay, something that nature created. And one of the ways that I will ask people to consider what an aqueduct is, one of the main differences between this and the other word is an aqueduct, first of all, is human made, okay? And just like we have air ducts in our houses or apartments that will carry air from one part of the building to another, an aqueduct basically is designed by humans to carry water from one place to another. And sometimes it carries it in an open ditch, sometimes it carries it in a pipe, or a canal, I guess, would be kind of like an open ditch. And so this is a very important distinction to be made, and it's very common that students, when they're given a test and asked about major terminology from this unit, the chance of getting caught up between an aquifer and an aqueduct and confusing those two words is quite high. So I want to draw attention to that and make sure that you are recording these two different definitions carefully and considering the differences between them as you write them. And again, this is an example of what an aqueduct can look like. Another one, and this is actually Winnipeg's aqueduct that we use to get water from our water supply, which is actually just inside the boundary of Ontario. And engineers over 100 years ago now built this channel, this pipe, really, and used gravity to carry the water from that lake all the way down to Winnipeg. And this is what the inside of it looks like when they were fixing parts of it recently in the recent times. So at this point, we're finished with the PowerPoint. This is the last slide that I'll ask you to consider, and mainly it's information that you would already have understood from earlier activities, but it's more visual, again, a way of looking at just how little of Earth's water is actually fresh water, and out of that fresh water, how much of it is actually able to be used by humans, because a lot of that fresh water is locked up in ice, which we can't easily get our hands on and use for all the purposes that humans need water for. So it's another visual representation of just how careful we need to be with our water supply in the world, given how little of it is actually usable by humans for most purposes. Okay, and again, the activity that follows is a bonus activity which we're not going to focus on at this time. So this will end our PowerPoint video. Thanks very much for your attention, and we'll talk to you soon. Take care.